Okay, so let's have a look at the 2024 Higher Level Leaving Cert Deferred Paper 1, and this is question 2. So in part 2A1, the first two terms of an arithmetic sequence are 3 and 10. Find the sum of the first 100 terms in this sequence. Okay, so what we're going to do here is have a look at 3 and 10. We're told these are an arithmetic sequence, therefore the next term should be 17 because the first term here is 3. And the common difference here is plus 7. We're adding 7 each time. So the next one then would be 24 and so on. So we want the sum of the first 100 terms. The formula for that is n over 2 times 2a plus n minus 1 times d. So let's just stick in the numbers. N here is 100. 100 divided by 2, 50. We want to multiply that by twice a, which is 3. So that'll give us 6, plus 100 minus 1, which is 99, times d, which is 7. Okay, so all we got to do is work that out. It's just simply calculator work. And when you do all of that, you get 34,950. So that's what you get when you add up the first 100 terms of this arithmetic sequence, starting with 3 and 10. Okay, so let's have a look at part 2 of part A, question 2. So the first, fourth and nth term of this sequence are the first 3 terms of a geometric sequence. Find the value of n. Okay, so our original arithmetic sequence was 3, 10, we said 17, 24, and so on. Any particular term for this arithmetic sequence is going to be Tn is equal to a plus n minus 1 times d. So in this particular case, a is 3, n is n, minus 1, and d is 7. If we multiply that out, we get 3 plus 7n minus 7. So that'll finally give us 7n minus 4. So this is any particular term in this sequence. So let's see, for our geometric sequence then, the first, fourth and nth terms of this sequence are the first 3 terms of a geometric sequence. So our geometric sequence then is going to be 3, that's the first. The fourth one is 24, and the third term then is going to be the nth term, which is 7n minus 4. So we've got to find the value of n. Well, if we look at our geometric sequence here, a is 3, and our common ratio then is, what do we multiply 3 by to get 24? Well, it's going to be 8. So in other words, our third term here must be 24 times 8. So our third term is 24 times 8. And that's equal to 7n minus 4. So all we've got to do is solve this for n. Well, 24 times 8 is 192. So we've got 192 is equal to 7n minus 4. Let's just bring that 4 over. So 4 plus 192 is 196 is equal to 7n. And then finally our n then is just 196 divided by 7, which is 28. And that's all we had to do, find the value of n. So this is our answer here. Okay, so this is part B. Use induction to prove that the sum of the first n natural numbers can be found using this formula here. So we have 1 plus 2 plus 3 plus up as far as n is equal to n times n plus 1 over 2. Okay, so the first thing we need to do is prove that the proposition is true for n is equal to 1. In other words, that P1 is true. So if we look at, first of all, the left-hand side, well, the left-hand side is just equal to 1. The first term is 1. If we look at the right-hand side, we have 1 times 1 plus 1 over 2. That's 1 times 2, which is 2 over 2, which is equal to 1. So the left-hand side is equal to the right-hand side. Therefore, the proposition is true for n is equal to 1, or P1 is true. Okay, so that's the first part. Let's move on to the next part. We're going to make an assumption here. We're going to assume that proposition is true for n is equal to k, or P of k is true. So that just means that 1 plus 2 plus 3 all the way up to k is equal to k times k plus 1 over 2. So really all we've done there is just replace the n with k. So we're going to assume that this is true, and what we want to prove then is we want to prove that it's true for n is equal to k plus 1. So in other words, that 1 plus 2 plus 3 plus all the way up to k plus k plus 1 is equal to, we just replace these with k plus 1. So we replace this k with k plus 1. We replace this k with k plus 1. And then we have this plus 1 here as well. Divide that by 2. So in other words, the right hand side will just become k plus 1 times k plus 1 plus 1, 2 over 2. So we want to make this equal to this here. So we're going to start on the left hand side, and what we're going to do is we're going to look at this part here and this part here and combine them. So we know that the first part, this part here, is part of our assumption. We assume that from 1 up to k is equal to this here. So we can replace this part here with k times k plus 1 over 2. So that's what we're going to do. So we're just going to look at the left hand side. This part here we can replace with k times k plus 1 over 2. And then we're just going to add this part on, which is just k plus 1 over 1 if you like. We can just put down here by the assumption. This is the assumption here. This is equal to this here. We assumed that that was true. Okay, so now we're just going to mess around with this and we're going to make it look like the right hand side. So let's do that. If we multiply this out, we get k squared plus k over 2. Here we've got k plus 1 over 1. I'm just going to add these two fractions here. So the common denominator is 2. So I'll get k squared plus k here. What do I do to 1 to turn it into 2? I double it. So I'm just going to double the top here. So it's 2k plus 2. That's equal to k squared plus 3k plus 2 over 2. We can factorize the top. So that becomes k times k. We have 2 times 1 plus plus. That works. And that's equal to the right hand side. If we have a look up here, our right hand side is k plus 2 times k plus 1 over 2. So we've shown that the left hand side is equal to the right hand side. So now we just need to write the final statements then. So we can say then that the proposition is true for n is equal to k plus 1, assuming that it is true for n is equal to k. But P1 is true. We proved that in step 1. Therefore, by induction, P2 is true, etc. We can say then that the proposition is true for all n is an element of n, for all natural numbers. Okay, and that's it for this question.